Hmm. Okay, some more components and circuits. This time we're going to talk about schematic diagrams.
Fun.
They're used to describe how a circuit works. In other words, how the parts are interconnected. So that you can look at that schematic and build the circuit, assuming you have the parts.
Mm-hmm.
It shows symbols for the components and how they're interconnected, and they tend to use standard symbols, so the schematics are kind of universal. They will typically indicate the type of component, what its value is, like for resistors or capacitors or inductors, possibly part numbers. They really need part numbers, or it'd be kind of hard to build it. Mm-hmm. They do not show things like what's used to interconnect, types of wire, length of wire, stuff like that.
Right.
Because you can build the same circuit different than somebody else.
Mm-hmm.
It's kind of a typical schematic diagram for some kind of little microprocessor board that has this Arduino chip on it and a couple voltage regulators and a USB to serial converter so you could talk to it. Fairly simple little board. But that's what a typical schematic would look like. You have sometimes more information in this title block, like who designed it and when and what revision it is, those kinds of things. So what is the name of an electrical wiring diagram that uses standard component symbols?
Charlie schematic.
Which of the following is accurately represented in electrical schematics?
Component connections, Charlie.
Okay, these are some standard symbols. Number one, we talked about, is how you represent a resistor. Number two, if you remember, is a bipolar transistor. Number three, you haven't seen before, that's a lamp. Mm-hmm. You don't see them much anymore, but old radios and things used to have little pilot lights to light up the dial. Mm-hmm. It was like a little flashlight bulb.
Yeah, so you can see where you're dialing.
Yeah. And number four is how we represent a battery, which is a collection of plates, which is because of, you remember we talked about volta, where we got volts from?
Yeah.
Well, he invented the battery, and it was a stack of plates. And that's what that's representing.
Gotcha.
And then number five is one of the ways we represent a ground symbol. You might see a couple others, but as far as this exam is concerned, it's this one.
Gotcha.
So, what is component 1 in figure T1?
Alpha resistor.
What is figure 2? Component 2.
That's Bravo transistor.
What's the function of component 2?
Supply electrical. Oh man,
Remember what's a transistor?
Charlie.
What is component 3?
Well, that's rough. That's a Charlie.
I told you these were hard.
Can't handle it.
What is 4?
Delta battery.
Here's some more. We have a
That makes sense.
an AC plug, like your household.
Mhm.
Number 2 is a fuse.
Makes
Number
sense.
three,
Yeah.
number 3 is a single pole, single throw switch. That's what the SPST means.
Single.
It means it only has one pole.
It's like
It can
opening
make
and closing the door.
and it's either open or closed.
Yep.
Number 4 is your transformer.
Is
The
that the
transformer
bulb or is that the parallel lines?
Well, that's the core. It may have some core material. Like if it was a power transformer, it's usually like laminated iron core. It could be a toroid made out of ferrite. But you'll have 2 windings, a primary and a secondary. And their magnetic fields interact. And that's how you get, if you get current flowing through the primary, it will produce a voltage and a current out of the secondary. And the amount is going to be proportional to the turns ratio between the two. If you had the same number of turns on each winding, then the voltage you see on the output would be the same as the input. If you had more turns on the secondary, then you'll see a higher voltage on the output than you saw on the primary. But because there's no power increase, if you had a higher voltage, you're going to have less current. Because it would have to be the same power or less as what came in. Number 5, you remember, is our diode. Mm-hmm. Number 6 is a capacitor. In some cases, they'll have 2 straight lines instead of this curved one. Mm-hmm. 7 is, again, a resistor. 8 is your light emitting diode. So it's a diode, and we have these little lightning type things showing the light coming out.
Oh, okay.
9 is your potentiometer or variable resistor. And 10 is that Zener diode we talked about. Mm-hmm. They're purposely made to operate backwards, and they will Zener or avalanche at a specific voltage. So this little circuit is actually a power supply. So you have your 120 volts coming in here. Mm-hmm. This is more than likely, even though it's shown equal, more than likely a step-down transformer. So this might be 12 or 24 volts. Mm-hmm. It's being rectified by this diode because, remember, it only passes in one direction. So you're going to get a half of the AC waveform. It's going to get partially stored in this capacitor to kind of smooth it out. It's going to light up this LED showing that there's voltage.
Right.
Okay. And this potentiometer is going to control the amount of current because this Zener diode is going to have a fixed voltage at this point. Mm-hmm. Not that you needed to know all of that. So, switches. Pole single throw switch is the most basic. Sometimes you'll see it shown this way.
That could be like a flashlight, little button and stuff.
Right. As opposed to a lever. Mm-hmm. Because they physically might be constructed this way. Mm-hmm. If it was a relay, more than likely its contacts were like this. Okay. You can have a single pole double throw, which means either way, I have one circuit that can connect to two others, either this one or this one. So it's no longer off or on. It's either connected to A or it's connected to B. Now, there's some versions where you could have an off in the middle position, but we don't talk about those. You can double it and have a double pole single throw, and those are mechanically connected together. So they operate as a single switch.
Okay.
And then you can have a double pole double throw, again, mechanically connected, but operating between two different circuits. Okay? So, what type of switch is represented by component 3?
Alpha. Single pole, single throw.
What is component 4?
Transformer, delta.
Okay. So we talked about diodes before, and now we're going to call them rectifiers when we use them in something like a power supply, like the one I just described. And in here, again, we're applying a 60 cycle sine wave through the switch into the transformer. We're getting a voltage out of the transformer, which is being rectified by this diode. And we're seeing a current through this resistor R1. So this is a plot. And the blue line is what we see over here on the input. The gold is what we're seeing over here at the resistor. So you can see we're only seeing the positive side of the sine wave that's going through the diode. The negative half is not being passed. And we call that pulsing DC because it never goes negative. It's always positive. So which of the following devices or circuits can change changes and alternating current into a varying direct current signal?
Bravo rectifier.
All right. It's still a diode, but it's being used as a rectifier. Okay, transformers. Here we see some kind of transformer core, usually some form of iron, because that's one of the best magnetic conductors. And we have a primary winding and a secondary winding. In this case, it's showing more turns on the primary than on the secondary, which means that our secondary voltage is going to be much smaller than the primary. So this would be what we call a step-down transformer. If we flipped it around and applied this primary voltage to the secondary, we'd have a higher voltage over here, and it would be called a step-up transformer. So it doesn't matter which way we use it. It's just the turns ratio determines whether it's a step up or a step down.
We had to use those in Germany for our American stuff from they're too.
And a lot of times you'll see them as equal. We call that an isolation transformer because there's no electrical connection between what's on this side and what's on this side. So you don't have any kind of ground loops or anything. So what component changes 120 volt AC power to a lower AC voltage for other uses?
Bravo transformer. And we're not talking trucks.
What is component 6?
Bravo capacitor.
Right. Sometimes we call them filter capacitors because it's trying to filter out or smooth out those DC pulses. So it's storing some of that energy in there. What is component 8?
Um, oh, 8 is LED, delta.
Okay. What is 9?
A Charlie.
Very good. Okay, here's some more. Now we have 2, which is a variable capacitor. Like that one we talked about where you rotated the plates.
Yeah.
Okay. And that's how we indicate the fact that it rotates. Number 3 is a variable inductor. And that's usually some sort of sliding mechanism that can connect with the different turns. And then number 4 is how we represent an antenna. And don't ask me who came up with that.
Probably based on the old TV antennas when Dad was on the roof going.
So what is component 3?
Variable inductor.
Right. What is 4?
Antenna alpha.
Okay, so we learned all about schematic diagrams and symbols, different components, the symbols for them. Transistors basically are used to control flow of current. We talked about single pole, single throw switches. We'll talk about single pole, double throw here in a minute, I believe. We use diodes as rectifiers to convert AC into pulsing DC, and transformers convert AC voltage to a different voltage.